afternoon. We have a wonderful presentation with our cohorts, and I just wanted to say hello to everyone and thank you for joining us on this talk this afternoon. We're letting a lot of folks in, so if you guys would just bear with me. You know, normally we get together and have conversations about things that are happening, and there's so many things that are happening, it's hard to keep it all straight. But I want you guys to know that our website, our social media platforms are all sending out information as quickly as we are able to acquire that. So we're getting ready for the annual conference in at the end of October. So if I don't quite get an answer back or get a comment to you guys, y'all bear with us because we have got a lot of things coming up at the annual conference. So without any other questions, I wanted to let you guys know that we are going to start this program here now. And we're going to tell you about Linda LaFontaine, who has just been a remarkable help to what's going on with the industry, HSP and PLS. And you guys know Linda, she works with a lot of conversations. She's the HSP cohort with neuro at McGill, and she's going to tell you about some new things that she's working on. So Linda, without further, let's go ahead and get you in and talk.
Okay. All right. Well, thank you so much, Norma, for the wonderful intro and for this opportunity. It's fantastic. So, like Norma just said, I'm Linda LaFontaine. I've been doing this for a few years. I've been building a cohort first of HSP patients. I'm also adding to the cohort of PLS patients. And this year I started bringing in some ataxia patients, all to research at the Neuro in Montreal. Now, I'm quite proactive, to say the least. I'm very persistent and I get involved in everything. But I'm not going to talk about all the initiatives that I'm doing because I'm doing a lot. I want to give patients as much time as they can have with Dr. Karamchandani. But before I turn it over, I'm going to highlight why I'm doing what I'm doing. I'm going to tell you guys what my goal is. My goal is always, always, always to advance science meaningfully through open science, all to benefit patients, to benefit us. I want to involve us in research. I don't want to represent us. And that's what the neuro does. They involve us in research. They empower us, and I want as many patients as I can possibly get to feel the empowerment that the neuro gives us. It's just fantastic. So we'll break down my goal to advancing science. So what I want to do. Well, sorry, HSP is kicking in. I'm getting spasms in my back. Anyway, moving on. I know doing good science is about making discoveries. Discoveries lead to diagnosis. Many diagnoses lead to care and cure, and that's what patients want. We absolutely, hands down, we want care and cure. But we have to start at the beginning. We have to start with discoveries. Discoveries, diagnoses, care and cure. 1, 2, 3. We have to start with 1. Okay. So I want to do this meaningfully. So I want to give researchers, doctors, clinicians the tools that they need to make good science. This is the cohorts are just one of the tools I'm using to give them the information that they need to do science. Doing it through open science, it permits us to do a whole bunch of different collaborations. Open science is the concept of doing science without barriers. So without barriers related to patents, barriers related to intellectual property. Now, we're not saying that those barriers don't have a role to play in medicine. We're just saying not in research. You don't do research in silos. You don't keep the information close to your chest. You share the information as much as possible. And that sharing permits all kinds of collaborations. National ones, me being from Canada, so Canadian province to Canadian province and territory. Then it permits international collaborations, like what you're seeing today. like an American foundation working with a Canadian Institute and Hospital. That's an example of an international collaboration. It also permits all kinds of interdisciplinary collaborations. And that's what you'll hear Dr. Karamchandani talk to us mostly about. That's his forte, interdisciplinary collaborations. It also permits what you're seeing right now, enter Linda. It permits a lot of, it permits patient partnership. And with patient partnership, it permits collaboration with patient organizations. So we're not just partnering with Linda, we're partnering with Linda's network. Linda's network includes Norma, and Norma's network includes the SPF. Eh? So it just grows, it grows like that. All right, so all that collaboration, that's what permits making more discoveries and launching patients onto the route to care and cure. Because like I said, discoveries, diagnosis, care and cure. This just accelerates us onto that route. The more research, the more discoveries can be made. The more research the neuro involves us in, the more they empower us, the more control they give us into our health that our diseases took away. Okay, so that's all I'm going to say about that. Now, it all starts with an email to me. Send me an email. My email is Linda, the letter J, my last name, LaFontaine, @gmail.com. I'll post it in the chat. I put it on Facebook. I hand it out like candy. Easy to find. All right. So what I do when you send me an email to participate, to give me I request your clinical information. You send me the email, I send you a registration link. That registration link, at the end of the registration form, in that link, you click submit, it goes right to CBIG. It doesn't come to me. I don't get your information. The hospital does. Okay. Now, at the end of the consent, of the registration, excuse me, that's step one. Registration is step one. Okay. After that, that registration triggers a consent. The hospital sends you the consent link. That's step two. Consent is like the permission to participate in research. It puts everybody on the same page. Okay. It tells you how the hospital is going to be using your information, what's expected of you. I'm telling you, for patients, it's trivial. It's trivial. It's not a big deal. But for doctors and clinicians and researchers, and remember, we can be doing this internationally. It's a big deal. Consent is a very important part before you enter into research. Okay, so step one is registration. Step two is consent. Step three, once you've done the consent, then you can exchange you can share the clinical information. I'm going to be asking you for two things. Well, I'm going to be doing the registration. The hospital is going to be requesting two things: your MRIs, your brain MRIs, existing brain MRIs. So don't go ahead and do something new, just the existing stuff. That's what we want. From national and international patients. International, anywhere in the world. And the MRIs can be, it doesn't matter, as long as they fit on a CD, they're good to go. They're valuable. Okay. The second thing that I'm asking for is saliva from Canadian patients. Simply, it's just a shipping issue. That's why it's from Canadian patients. We're going to be using Canada Post to do this. So existing brain MRIs and saliva samples. If you can contribute that to research, that would be fantastic. And all that starts with just an email to me. So with that, I'm going to turn it over to Dr. Karamchandani. He is a neuropathologist, and he's an associate professor at McGill University. But for today's SPF talks, the most important thing to know is that he is the scientific director of the CBIG Open Patient Biobank at the Neuro in Montreal. Take it away, Dr. Rockstar.
Linda, thank you so kindly. And thank you all for your time this evening. I hope to give you a little bit of perspective about how we make progress in medicine. And I've been a doctor for 16, no, more than that, 20 years. I'm getting old. So let's go through a little bit of history together. So this young man back in the 1700s invented the microscope. I'm a pathologist, so I care a lot about looking at cells in the microscope. This is Leeuwenhoek. He was a Dutch man who he developed a new way to polish lenses. And with that, we were allowed to look at cells. This is a Frenchman, René Théoloff Laennec. He was the first doctor to use the stethoscope to listen to sounds and then correlate it with how people did clinically. This is an example of when we learn, when we have data, we make progress. So this is a little bit cancer specific, but this guy is Robert Virchow, who was a German pathologist. He was the first guy to think that maybe diseases evolved from cellular pathology. He looked at cells under the microscope and he said, maybe there's something about the way that cells behave that cause pathology. And indeed, his theory has been durable for more than 150 years. Here's where we have hope. This is a smear from a 7-year-old boy from Texas. Now, this smear is about 10 years old. So this boy presented to the emergency room with bruising. And within 45 minutes, he had a blood draw and he was diagnosed with his leukemia. And what you see on the bottom right side of your screen is the progress that we've made in this disease over the last 70 years. In 1950, if you walked into the emergency room with this disease, you typically succumb to your disease within 6 months. That is no longer the case. In 2025, we will treat these patients durably with more than a 90% success rate in certain kinds of leukemia because we've made such tremendous progress. Now, the progress is possible because this is another pathologist. This is Sidney Farber, who was the first person to use a chemical to try to alter the behavior of this disease. So what I'm trying to explain here is that when we have cells and data, we make progress. The reason that we made such progress with leukemia is that it's not hard to get those cells. You put a needle in someone's arms, you could take those cells and look at them under a microscope, you put them in a dish, you perturb them, you alter them, and you can learn about the disease. That's the key to driving science. Data and stuff. So you can compare that to other neurological diseases. Okay, so I just showed you leukemia. 1950 to 2025, we've cured 90% of those patients. What are we doing for Parkinson's? Very little. What are we doing for HSP? Very little. And the reasons is that we don't have the cells and data that we need to make progress. So I'm going to give you another story that I find very inspiring. This is a very real case from 2014. This was a 7-year-old boy. I'm sure many of you have children on this call. I have 3 children, and he presented with weakness of one hand. Now, I got to tell you, if one of my kids complained about their hand feeling funny, I don't know if I'd take them to the ER, but these are the good parents, took him to the emergency room, and it turns out he had a brainstem tumor, 11 centimeters. Okay? So you see a little arrow there. That's where they took a little piece of the tissue. And I'm going to brag here because for the Americans on this call, these are not inches, those are millimeters. So it's a submillimetric biopsy. And this is what it looks like under the microscope. Now, I can tell you that this is not normal. And very importantly, this is a neurofilament stain. So all of your connections from your brain to your limbs go through your brainstem. All of the brown things you're seeing here are the wires that connect your brain to your arms and your legs. It's obviously not a place that you want to take any tissue out. Don't worry about the technical details, but the brown dots you're seeing here are cells that are dividing. What that means is that this tumor is proliferating. And if you don't take it out, unfortunately, you'll have an adverse event. Now, in 2015, we have an antibody that detects specific mutations. And this particular mutation, the details don't matter, is in BRAF. But we diagnosed this off the same piece of tissue, and we started the patient on a mutation-specific therapy. Now, this is what rocks, okay? This is 10 years old. This kid had an 11-centimeter tumor. He got started on mutation-specific therapy. It shrank to 2.2 centimeters. And this kid has had a durable response for over a decade. That is magic, right? We have altered the natural history of a pathology that was incurable when I did my fellowship. That's what we're aiming for. My brother is a type 1 diabetic. He was diagnosed at 3 years of age. He's 44 years old. 100 years ago, you die. We changed the natural history of that pathology. That's what we're here to do. That's medicine at its best. That's why we're here today. So I'm very proud to be at the Montreal Neurological Institute. For all disclaimers, I'm a US citizen and a Canadian citizen. And I came to Canada to work at the Neuro, because the Neuro is one of the most brilliant neurological institutes on the planet. And I believe in what we do. And so about a decade ago, the Neuro committed itself to open science. And as Linda already pointed out, that's about making everything available to everyone that has a meaningful question around the world. We do not keep things siloed. We share openly. So Linda has been our partner for many years, and the CBIG repository, CBIG is an acronym, stands for Clinical Information, Biospecimens, Imaging, and Genetics. It's a clunky acronym, but it's basically all of the stuff that we need to make progress. We consent patients, we collect their samples, we collect their data, and we share it openly. The goal is to accelerate our ability to make meaningful interventions to improve patient care. Fundamentally, like we saw with the leukemia, when you have the cells, you can understand the molecular biology that drives disease. So we're here today for HSP. There is not a lot of cell lines for HSP. There are more mutations in HSP characterized than there are open cell lines for HSP. We have to change that if we're going to make meaningful progress. I've already talked about leukemia, but there's wonderful stories about how we really can alter our ability to treat patients in the world of pediatric oncology. So I've listed 3 different kinds of pediatric tumors: osteosarcoma, Ewing sarcoma, rhabdomyosarcoma. All of those are pathologies that were incurable that are largely curable today. So, who can we consent from? Well, luckily, it's almost anybody. It's grown-ups, it's kids, it's people who need substitute decision makers. We can take consent before a procedure or after a procedure. And if you're asking, what can we collect? We can collect almost anything. Now, that's true for in our hospital, but from the larger HSP community, we're basically talking about, as Linda said, saliva, because we're looking to collect DNA to understand the genetics of this pathology. And one thing, Linda, I'm going to correct you just a little bit. We can actually collect samples from patients around the world. We do have an international consent form. It's an additional step after the online consent, but we're happy to do that. We can do that by email, but we can consent patients from around the world, and we've done so. We try where we can to collect as much clinical information as possible. Now, Linda already talked about this, and I saw Rawan is on this call, where we can collect MR information along with the genotype. That would be really special because Rawan is working on a project to understand the radiologic features of HSP associated with different mutations. But we collect all kinds of stuff, okay? We collect clinical information, we collect imaging, we collect genetic information. The goal originally was to try to collect stuff so we could actually study those cells under the microscope. And it worked. So this seems like a weird little blob on the left side of your screen. When I was in medical school, this was not possible. What you see on the left side of your screen is a mini brain, an organoid. It's a blob of cells that specifically express neuromelanin. Those are the parts of the brain in your brainstem that are diseased in Parkinson's disease. When I saw this in 2017, I almost jumped through the roof because this was not possible. But now we have those cells under the microscope. And by the way, this comes from a patient. We had a patient with Parkinson's disease. We did a blood draw. We took those, the nucleated cells, the cells with the DNA, reprogrammed them, and turned them into an organoid. That's how we make progress. So this is possible. You're looking at a mini brain from a patient with Parkinson's disease. You take that, you take the control, and you can make progress. This is how we're going to go faster. So in 2025, we've collected more than 100,000 samples from 6,000 patients. We have huge cohorts in the diseases that we see. That's Parkinson's, multiple sclerosis, neuromuscular disease, rare neurologic disease. What we would love to do is to make sure that we collect more patients with HSP. We've collected more than 200 patient-derived cell lines. So the organoid I just showed you is one example of a cell line that we derived from a patient. And I have to balance the complexity here. But when a patient has a mutation, we can correct that now using something called CRISPR. It's a DNA editing technology. So almost all of our cell lines actually have a normal control. And that's really incredibly useful for scientific research. And we partner with people all around the world. And I'll talk about that a little bit more. So I do have to acknowledge that I work with very smart people. And we're incredibly lucky that we have access to this incredibly unique informatic infrastructure that incorporates all of the stuff that we're talking about in the same place. Now, I guess we're all on Zoom tonight, and we all know Microsoft Office, but I got to tell you, in the world of science, there isn't something like this. This is the only database that I'm aware of that takes your stuff, your data, and puts it all in the same place. And it's openly available now. You can all Google CBIG Loris and search our online portal. And if you register, you can see what the individual patient data is versus the open data. We share our data as openly as we can safely. And this is an example of our open cell line catalog. As I told you, we have more than 200 of these. I'm focusing on Parkinson's here. We have one HSP cell line. I think we can do better than that. And I'm very happy to say that not only have we done this for the brain, but our colleagues in cardiology at the University of Ottawa are actually using the same platform to host and share all of their data for cardiac pathologies as well. So what we built for the brain works for other diseases as well. We recently in this year have incorporated more than 20,000 bioinformatic data files. These are genetic studies for many patients, and more than 100 pathologies have been sequenced, and we can share this data openly as well. And I think for HSP, I think that's one of the most noble goals we can do. This is too technical. It's all kinds of different data. It's whole genome, exome. It's multiple kinds of bioinformatic data. And as you can see here, this is the Canadian Open Neuroscience Platform. We've shared more than 79 data sets openly around the world. And I'm very happy to say that my much smarter colleague, Ziv Ganor, received an $8 million grant to sequence all of our patients. So we have 6,000 patients. Almost all of them have already been sequenced in some form or another, but it doesn't matter who you are. We're going to do the sequencing. We have medical geneticists. We reach out back to the patients. If there is anything that we can do to improve your care, we will ask you if you want to be contacted. And if you say yes, we will do our best to improve your healthcare. We will give you those results. Now, it's a research result, so you have to go back to your clinician and say, this is what the research result showed, but we do the best we can to improve the care of the patients that participate in their altruistic donation. This is not easy. So we're on the bleeding edge of research and science, and we have to be very careful about the law and the ethics. And as a dual American and Canadian, I'm very aware that we have different challenges at these days. In Canada, there is a law that says you cannot be discriminated against based on your genetics. That's not true in America. So we do have to be cautious. We do have to be careful. When you make these contributions, we do our best we don't do our best, we literally de-identify you in our database. There is no way to go back to who you are from the data portal that you can search on CBIG. There's no names, there's no date of birth. We don't do that. Those things are kept very separate, and they do so intentionally. We have 3 levels of access. We have open data, which is almost like metadata. It's telling you who, what, and it's not identifiable. If you are a researcher and you log in, it becomes traceable. So we know who you are. We can see the data that you're looking at. And if you're looking for bits and pieces of people, that's controlled access. That's the highest level of security. There, you actually sign a legal agreement. We know what your question is. We make sure that you have the appropriate ethics, and we send you the samples or very controlled data. That's true for all genetic information, by the way. So there we go. I've come this open, registered, controlled. Now, our goal is to go as fast as possible because we don't have time to waste. So our quickest exchanges, even including the lawyers, have been in 4 days. So if people need that information, we can go fast. We have templates. Our whole, as Linda already said, we don't do IP. There's no intellectual property. We got most of the obstacles out of the way. If scientists need the data, we will get them to it quickly. So I think HSP is one of our patient-facing successes. Thanks to Linda, we contacted patients from across the country, collected samples, sequenced their genomes, and in 40% of patients, we identified their pathogenic mutation. And these are all patients who had never been diagnosed molecular before. That's the goal. Even better, to collect their cells so we can make cell lines to study the actual molecular biology that's driving the pathology. So this is just an example of all kinds of partners. We've had more than 130 collaborations across the country and around the world. We partner with industry. We partner with academic institutions. This is out of date. This only says 11 countries. We're at 14. We share everything we can with anyone because that's what makes progress. Now, one thing that's unique to this is when we share stuff, we want to get stuff back. So if we give something to someone and they do science, we want to know what their data shows, and we want to be able to share that data with other people. So this is an example. Now, Merck is like an international pharmaceutical company, and they're willing to share their data with us. We sent them 50 Parkinson's samples and 50 controls. They looked for an antibody against a certain protein. They did their science, and they sent it back to us, and we share that with other scientists. And that's true for Takeda as well. Takeda is a Japanese pharmaceutical company, and we sent them samples from patients with amyotrophic lateral sclerosis. And what you see here is two things. One, they shared their data back with us. And two, we are very careful about how we handle these samples. So their goal was 75% of cells should be viable. And with the protocols we used, we had more than 87%. There's another element to all of this, is we are in an era where we're currently developing new clinical trials based on genetics. So this is a couple of years old now. This is for ALS, and there was a clinical trial to a specific mutation that causes amyotrophic lateral sclerosis, ALS, and Lou Gehrig disease. We screened our cohort and we found 4 patients. Now, this is a rare disease and this is a rare mutation. I think HSP is a rare disease. And we all know that HSP is a collection of different mutations. So when we do precision medicine, we need to know which patients might benefit from the therapies that are specific to their genetics. So this was a fun story because we found 4 patients. Not all of them were healthy enough to go on the trial, but the one patient that went on the trial lived for many years. The ALS is incurable. It's a wonderful start to identifying drugs that work for specific mutations for rare neurologic disease. So I've talked too much. I want to thank Brain Canada. They funded all of our work. And I got to thank the Tenenbaum Open Science Institute and my excellent colleagues who have supported all of this work. And of course, Linda, thank you.
Okay, now that I've unmuted, you're super welcome. I'm not done, but we're good.
Well, let me ask this. Does anyone have any questions that they would like to ask the doctor? That was an interesting perspective on many things. I really look forward to some follow-ups. Anyone have any questions? I see hearts. Josie, you got a question? Go ahead, please.
Yeah.
Unmute yourself.
Yeah. Do you hear me?
Yes, I do now. Go ahead, please.
Okay. I have SPG7, and my two daughters participated to the saliva test, and one of them is very worried. So she saw the genetician at the neuro, and he told her that SPG7 may mute into a dominant form. So how will she know if her gene eventually turns out in a dominant form? And you said that you wrote returning to patients who want to get their results. So she never got her results. She didn't know she could ask about her gene mutation. So yeah, so this is my questions. Yeah, because she's very worried.
Je
Thank you,
comprends.
Josie.
José, ton fille, est-ce qu'elle est dans le CBIG?
Oui,
Oui?
oui,
Moi, je suis, so I'm just going to speak in English.
Yeah.
Thank you.
I don't know who has been sequenced or has not been sequenced. I don't have patient level data. It's
not
so
everyone has been sequenced. She
not
was one
yet,
of the first ones. Okay,
not yet, but certainly everyone who will be sequenced
okay,
will be offered the opportunity to hear about their results.
okay, okay,
Just gonna take a
okay.
while.
So eventually she might be sequenced. Yeah, because she gave her saliva. She was one of the first ones. Yeah.
So she will be sequenced, and when we get those results, we'll be definitely happy to share it with her.
Okay, thank you. I will tell her.
Thank you, Josie. Tina, you got a comment or a question? Unmute and go ahead, please.
I think there was a bunch of people ahead of me, but if it's real quick, I just had a question for Linda and I sent it to her in the chat.
Okay. All right. Thank you, Tina. Jackie,
Okay.
Jackie, you got a comment or a question? Oh, wait a minute, she's unmuting. So Dr. Tina says, how do I get you the saliva? I'm at that stage.
So what we have to do first, as Linda said, you need to sign a consent form. Then we send you a kit through the mail. You provide the saliva, it comes back to the neuro, and that's what we use to sequence the genetics.
Because I think that I have already done the consent. Linda did with Dr. LaPiana. I was trying to do like the MRI study or whatever, and I sent my MRI CDs in.
Okay, so Linda can take a look and check on that.
Yeah.
Tina,
Okay.
that's what I was going to say. It took mine almost 4 months. I mean, I had given up, but I was getting ready to call and order new ones. But it takes a long time to get to Canada.
Yeah. Yes.
Thank you, ladies. Jackie, do you have another comment or question?
No, that's all I was going to say.
Okay.
Don't give up, people, because it takes a long time.
Thank you.
So-
Beatty, you got a comment or a question? Go ahead, dear.
Hi. Yeah.
Hi.
All I wanted to ask was if I do have an MRI and it's I believe at least 5 years old, does that still count, or do you need something more recent?
Well, I think Rowan is on this call.
She is. Go ahead, Ramon.
Hello.
Rowan, you can answer this question because I think it's useful, but you can as the expert, you can comment here.
Yeah, so I'm Rowan. I'm a PhD student in Dr. Roberta's lab, and it would be absolutely phenomenal. The first leg of my project was trying to compile all the MRIs that are published from HSP patients. I think I have around 60 MRIs, which is nothing when it comes to actually trying to discover patterns. So anything you have, regardless of when it was the disease started, before the disease started, yesterday, all of it would be phenomenally helpful.
Okay, great. Okay, I'll try to find out where that is. Thanks.
Right. I have a question.
Go ahead, Mario.
Well, hi, how you doing? I did a genome and I did the MRI. I have everything, but the lab is uncertain about my clear diagnosis. So I'm not sure if it's HSP. I'm certain it is because I do present that way, but I'm just curious to see how I could send stuff anyway, because I do have a lab does have all my stuff, but I do have the MRI myself. I do have it in personally, so sorry, I'm just having a tough time talking.
No problem at all.
Hey, I can
Um,
tell you guys, I can tell you that if you can see your chat box, if you'll start at the very top of that, the first thing that you've got to do is send an email to Linda, and her email address is in the chat. And then you can see step 1, step 2, step 3. So for those
okay.
of you that didn't catch that, and then also this will be uploaded to our YouTube channel. So as soon as this is all complete, you can go back and see the instructions and the information.
I think, Mario, that you brought up something that's incredibly important, which is that HSP presents in all kinds of different ways. And people mostly spend years being misdiagnosed or undiagnosed. And actually, there are many pathologies where we kind of put a label on it, but it's a collection of different diseases. And I think that HSP in particular is not well understood. And the more that we collect and the more we learn, the more we have a likelihood of making some kind of progress in what is, in my opinion, a neuron disease, motor neuron disease, ALS, PLS, HSP. Fundamentally, they're a motor neuron pathology, and we'd have to do more to understand these different pathologies.
Okay, thank you very much. Jackie, you got another comment?
Yeah, I do. Linda, did I understand it right? If we're in the US, the only thing we can do is MRI, right? We can't do anything else.
Oh, I'm on mute.
No, you
Can
go
you
ahead.
hear me?
You're talking.
Yeah.
Okay. I never know if I'm on mute or not. I'm not sure anymore. I thought it was just Canadian patients who can contribute saliva. Specifically, what can international patients do? I've been asking for MRI scans. I'm asking for Dr. Karamchandani.
Yeah, so we can actually collect samples from people from around the world, and we've done so many times.
Okay,
so what's the process? How do I?
So you have to email Linda, then we.
Well, I've already got the MRI with her, so I'm already, I think, signed up.
Everything is already in CBIG.
Right. So she's already got my MRI, so I just wonder what the next step is.
So we would have to send you a saliva kit collection, and that would come back to the neuro, and that would be sequenced.
Okay.
Great. Those are great things. Okay, Jesse, you got another comment or question? Go ahead. You'll have to unmute, dear. Unmute.
Okay, there's two Jose. Yes, I registered with you, Linda, with CBIG. I'm in Quebec, so I'm very close by to the, and I can't remember. I never received the saliva kit, but then I was told that since I had been, I'm in a bank of another research center, it got transferred or connected. So anyway, so I was wondering if the MRI is the same thing, if you follow me. I know I had MRI, but I don't know if the CBIG had access to it through the Quebec, Quebec file. So, or do I have to provide more?
Je suis bien fier qu'ici au Québec, on a accès à tous les scans cliniques Pour la
Okay,
Provence.
so it means you had the scan on file. Good. And the saliva is the same thing. It's probably it. I can remember. I know I got an answer that since I was participating in another research, it
Yeah.
got communicated.
So
Correct?
you're probably part of CAN HSP, which
Right.
is led by Dr. Rouleau and Ziv
Yep.
Ganor, who are
Right.
very much our close partners in all of this.
All
So
right.
we actually double check to make sure we don't waste money. So when people have already been sequenced, we don't resequence them.
Okay, good. Sounds good.
Thank you.
Thank you for your work.
Yes, thank you, Josie, too, for your questions. I really appreciate that, everyone. All the comments, the questions. Well, that's what we're here to do, is we're here to learn. We're here to understand what are the steps. How do we need to get on this roadmap and make this plan happen, right? So we know from the conversations that now we've had with you, Dr. Jason, and thank you so very much for your time, and Linda for all the work that you guys are doing. There's a lot of development that's taking place all across the world. I am just astounded at the various pieces and components that are seeming to come together. Is there, before I go any further in anything, is there anybody else that has any comments or questions that they'd like to add? Now's your time. All right, you're going to have to listen to me. All right, so thank you again, Doctor. I'm curious about the more collaboration that you are doing with other places across the world. We have several components of research that are going on across everywhere. And particularly, I can talk about what we see is happening in the United States. What I'd like to see is how do we work together in pulling all the various components of research into a roadmap that says, here's what we think are the small molecules or the medications or the therapies that can be available to help each and every one of us. I mean, we're rare, right? Each one of us are rare, but we actually have motor neuron degeneration going on. How do you see where we need to get to that level of therapy?
That's
Can
a
you comment
wonderful
about that?
question. From my perspective, it starts with actually developing cell lines. At the neuro, we have one HSP cell line out of our 200. HSP is not one disease, it's
Yeah.
many different mutations, right? We all hear this. I'm SPG7, I'm SPG4. We need to create more robust collections of cell lines to study this disease in a way that allows us to make progress.
Well, and I think that there are some other organizations too in the United States that's doing what you guys are doing. So my point is we need to be trying to get you guys all collectively together. So not only us as the patients that need to collect with your studies, there are other institutions that are doing similar work as to what you're doing. So we need to figure out how we can bring everyone together and discover where is the gap of what we need for each patient. I mean, how many patients do you think you have in your database now that have HSP and PLS? We represent
Oh,
primary lab.
PLS, yeah.
Yes,
We're,
sir. So we
we're
need to
probably
talk
about
about
100
some of those
people.
numbers. Altogether collectively, 100?
Yeah.
Okay. That's good to know because we need to figure out how we can work with some others. We think that Dr. Fakari at Boston's Children has a database of like 300. So, or maybe more actually by now. So we've got to figure out how we can work together with what you guys are doing and what's happening. And even like the Europeans, there's some other things that are happening with those folks as well. And we need to find ways that we can work together on these collaborations. So this is
Our entire goal is to be interoperable. We want to share with everyone we can. So however we can make that progress, we're here for it.
Good. Well, one of the things that we're also doing at this year's annual conference is we are working with a contractual agency that's called Critical Path Institute, and they are bringing together the science that has been done and how all of the collaborative efforts are working so that we can figure out what real translational science needs to be while we are then studying it clinically and how it's going to be applied to each and every patient. So we've got a lot of little moving mechanisms going on. And we would love to have you greater and deeper into that collaboration. I'd love to connect you. I thought Colin was going to be able to join us today, but he got called away. So I'd like for us to figure out how we could work together in that collaboration. We're bringing all of these folks together, as well as with our Spastic Paraplegia Centers of Excellence Research Network that Dr. Vakari is the primary investigator for. They just announced that they have gotten an $8 million grant from NIH for them to be doing the SP CERNs for the HSP and PLS patients. So we're very excited about where we're going to be heading this next year and what may be coming from the conferences as we get to Washington, D.C. So this is going to be great news. Did I lose the doctor? Oh, there you are. I see you. I see. I thought my whole computer just glipped. Anybody else? Jackie, you got another comment or question? Go ahead. Oh, you're
Oh,
on
you're
mute.
on.
You're still on mute. I don't know what's happened to her computer.
I'm muted, Ian.
There you
I
go.
said the grant actually came through or it's still on hold?
No, it's approved today. We got an email today.
Thank goodness. Okay.
Yep, yep. Good news. We'll be sending that to you guys. I just have been so busy. I texted. I was going to text it, but anyway, Betty, you got a comment or a question? Please go ahead. It's so good to see you.
Yeah, this question, not to be morbid, but and I know right now our HSP isn't supposed to kill us. And I've got a huge timeline between the time my father died and the age my mother died. So I'm not saying I'm dying tomorrow, but
That's right.
yeah, is there research, you know, if we grant our cadaver to science, so we're definitely talking future, but is that information something that will be translated to the neuro?
That's a very interesting question. And I have to be a little ashamed. The only way that this works are patients in the Montreal area. So
Oh,
we do accept post-mortem donations, and the science is incredibly valuable. It's really it's an altruistic donation. It's a gift, and it's very valuable. But currently, we only do that for patients who are, within the immediate vicinity.
mhm,
I think there we also carry that information on our website. If you're located in the United States, there is a brain bank, but there are some specific rules on how quickly that has to transfer. So it's one of those conversations you need to have with your family so they understand that time is of the essence.
mhm.
Otherwise, that tissue is really not usable.
It has to. I just went through this with Dr. Zuckner, with my aunt, and it has to be within 24 hours of death that they can harvest or things start changing. And you have to make it these. You have to get everything ready and prepared way in advance, because if there's not somebody there to do the autopsy and harvest the brain and spinal cord that day, you're out of luck.
Yep.
Mhm.
Yep. Thank you, Jackie. Linda, you
Okay.
got a comment or a question? Go ahead.
Yes, the brain donation is an important subject. So if we're done talking about that, that's fine. I'll go. But I don't want to bump anybody off.
Well, hang on just a second. We got Josie over here that wants to have a question. We'll come back to you, Linda. Go ahead, Josie.
Well, it was about the brain donation also.
Oh,
Can I?
Go ahead. Go ahead.
Okay. I want to give my brain when I will die. So I did many phone calls and writings. Because I'm Canadian, I cannot send it to United States because of les douanes, on dit ça comment, les douanes?
Customs.
The border, because of the border, it may last, it may. And in the province of Quebec, at the neuro, they told me to call the Douglas, but the Douglas, they told me that they don't take it anymore. So it was really, it was really difficult. And for my part, the only place I found was in Nova Scotia, where I filled papers and they told me how to do. But even in the province of Quebec, it's really, really difficult. Yeah.
I'm sorry to hear
And
that, Jose, but I
yeah,
promise if you want to work, we were happy to work with you, and that's something we can do with the neuro if everything,
okay.
yeah.
Yes, I would really like, but when I called the neuro, they told me to call the Douglas. And the Douglas told me that they don't take brains anymore. And certainly not for HSP.
So
So
and I've got to be very sensitive to this. Currently, we do
Thank
this for
you.
people who seek medical assistance in death in the province of Quebec,
Mhm.
because as we talked about that 24-hour window,
yeah.
it allows us to make sure that we can that we are taking tissue in a timely manner that improves the scientific yield of that incredibly gracious altruistic donation.
Mm-hmm. So I may write you so you will tell me how to do.
We'll work together.
Okay.
There you
Okay.
go.
Thank you.
Thank you so very much, you two. Linda, you got a comment or a question?
Okay, well, I'm going to go back to the chat. There is a question from Eric Mace about in vitro saliva tests, or they do or DNA testing, if the data from the testing would be useful for CBIG.
I'm sorry, Linda, I'm not sure I understood the question.
He's asking if we received genetic testing and diagnosis at Invitae several years ago, would we redo the saliva test, or would it be helpful to have the data from Invitae? So can you benefit from the data he already has?
I guess I don't know what Invitae means.
It is a company. It is a company that collects information from patients, all the data that they themselves, like they've sent to you, they're sending to you. This is their carrier at this moment in the United States, Invitae. You can find them on access on our website.
I'll definitely take a look at that.
Yeah.
Okay, so I guess that makes a big difference. Invitae would be like the
I doubt
CB.
Invitae would share unless there was some memorandum of understanding, or if the patient
Okay, so
communicated to let you guys have that data. So
okay, so then it would be a better idea for Eric to do the saliva test than to go back to Invitae to send the information to
probably,
CB. Okay.
Probably.
Fundamentally, there's a difference. So I don't know Invitae. I'll have to Google this and learn. But we share our data with all scientists around the world. We've done this for ALS. If once we have the data, we share it. We're not a company. Our
Yeah.
goal is to advance science. Full stop.
Well, Invitae, I had a genetic panel with Invitae, so they use it, in Quebec. They send it at times to Invitae also to have the genetic panel to get our diagnostic. So
Okay, there is I'm going back to the chat. There is a Brian Walsh who's got a question. He doesn't say what his question is, but he doesn't know how to raise his hand.
Oh,
Well, Brian, can you hear us? Go ahead.
Yes, I appreciate what the doctor's doing. I'm a patient. I live in New Jersey, but I've seen Dr. Fink a few times, and the saliva collection sounds great. I don't know if we could reach out to doctors like Dr. Fink who specialize in with a lot of people who have HSP to collect the saliva, because I would think 9 out of 10, 8 out of 10 would say yes for the cause, and just collect. I would think you would be getting tremendous amount of data and saliva if you find one or two doctors like Dr. Fink.
oh,
That-
you okay?
That is one of the things that I had said basically earlier, is trying to get the collection of the CERN doctors, or, any of the others that are in the network of SPF, to work collectively and having conversations with Dr. Jason so that we can make a collaboration in those kind of efforts. So I think that's one of the things that we need to do. And that's one of the things that's actually coming out of the conference in Washington, D.C., as we're working with CPATH and who's helping to try to get that information for us and cause these connections so that we can find the gaps. So maybe, Brian, that would be a good question. If you're one of the speakers, you can communicate and provide questions to the conference, then we'd be able to ask that question. There you go.
Okay, I think there was a little delay, but I got it. Could I ask another question? I mean, I have HSP, and I don't know. It's not really scientific, I guess. To me, I see my brother; he's struggling much more worse than me. And are there any people with HSP that use exoskeletons?
Yes, there are, as a matter of fact. And we had an SPF talks about that not too long ago. And
Okay.
I'd love to invite you to watch that YouTube video because it is a phenomenal conversation that we had about exoskeletons, and some information is available on that YouTube.
Okay, and I'll check it out. And
Yeah.
I guess there are some people from Canada. The one company that I saw that was pretty interesting was Kigo. They had the exoskeleton. I don't know if they were in that video, but I've seen some of I looked at a few companies, Rewalk, and I guess I'll do a little search on the web. But I
Well,
think, okay.
well, let's just ask. Hey, you guys shake your hand. Any of you on screen today been a part of any kind of exoskeleton discussions or use? Anybody? No, nobody's. Well, there you are. But there is, we had a great SPF talks about exoskeletons and the different things, the components of that. So I'd
Right.
love to invite all of you to watch that on our YouTube channel.
Okay, I'll take it out. I appreciate it.
Hey, does anybody else have any questions for Dr. Jason? This has been a most interesting conversation, or for Linda. I appreciate it. I know you guys know that we try to keep these at 1 hour basically, and that we have met that and actually over. So thank you, Dr. Jason, so much for speaking with us and having this conversation, Linda, about the importance of working together, and open science is absolutely important. We very much realize that. And Ruwan, the amazing work that you're doing, thank you so very much. That is phenomenal database of pulling all that together. Tina, you got a comment or question? I'll let you have the last one.
Well, actually, it's a question that Brenda Lewis put in the chat.
Oh,
Is
okay.
saliva, what's the difference? Is it better than blood, or what was the question?
There you go. Is saliva just as good as blood? That's the
So
question.
for DNA, yes, saliva is just as good as blood. But with blood, for people who are at least in Canada, and actually we've been able to collect this from around the world, we can take the blood cells that have your DNA and turn them into cell lines that allow us to reprogram them into motor neurons and study them under a microscope. So blood has different advantages, but from just a genetic standpoint, saliva and blood, same thing.
There you go.
Um,
That's
And
important.
saliva is more, you can put it in the mail and it remains, the DNA remains viable. You can't do the same thing with blood.
DNA
So,
is DNA. It's very robust. It's the reason we know how dinosaurs lived. It's very, very durable.
yeah, there you go.